Okay, so lastly, we're going to look at this one here. So same idea as before, we're going to find our zeros. Okay, so we're going to factor this. In this case, I'm going to test f of 1. Looks like it's a good one. Looks like f of 1. 1 minus 1 minus 11. Oh, that's not going to work, is it? 1 minus 1 minus 11 minus 10. No, that's not going to work. That's not equal to 0. Okay, I think negative 1 won't work either, will it? Negative 1. Negative 1 minus 1 is negative 2. No, that's not going to work. Okay, so negative 1 doesn't work either. Okay, so let's try maybe, this one's getting a little bit tougher, so let's try maybe negative 2. F prime of negative 2, or f of negative 2. When I plug in negative 2, I get negative 8 minus 4, so that's minus 12, plus 22 minus 10. Yeah, that's equal to 0. There it is. So when I write my factored form for this, I'm going to end up with x plus 2 as one of my factors. Break that down. So plus 2, 1, negative 1, negative 11, negative 10. I'm going to subtract, times, and subtract, times, and subtract, and we should end up with a remainder of 0. So I'm going to then end up with x squared minus 3x minus 5. Well, that's not factorable, so I'm going to have to solve that using quadratic formula. Okay, so x is equal to 0 at x equals negative 2, and then I have to solve that quadratic. X is equal to 3 plus minus square root of 3 squared, negative 3 squared, minus 4 times a times c, all over 2a. Okay, so simplifying that, that's going to be plus 20, so 3 plus square root 29 over 2. Okay, and the decimal equivalents for that are, okay, just working that out on my calculator, 3 plus square root 29 divided by 2, I'm getting 4.19. Okay, and 3 minus square root 29 divided by 2 is negative 1.19. Okay, so if I were to draw my roots in here, let's say that's negative 2. That's going to be 3 minus square root 29 over 2. And then we're going to have point somewhere over here, that's about 4.19. So that's going to be my 3 plus square root 29 over 2. Okay, so those are my zeros. Okay, I want to find then, using calculus, my turning points and inflection points. So turning points are my min and max points. So I need my derivative. So I'm going to go f prime of x equals 3x squared minus 2x minus 11. Okay, I should try factoring that. I think that might be factorable. No, that doesn't look factorable, does it? 3x squared, negative 11. Yeah, I've got to multiply to 33 and add to negative 2. So that's not going to work. So I'm going to find my second derivative zeros by quadratic formula again. So 2 plus minus, so I'm finding where that's equal to 0. Square root of 4 minus 4 times 3 times negative 11, all over 6. So I'm getting 12 times negative 11 is 132. So plus 4 is 136. So square root 136 all over 6. And 136 is divisible by 4. So I'm going to end up factoring that out. So I'm going to end up with 2 root 34. So that's going to simplify to 1 plus minus square root 34 and divided by 3. Okay, so the decimal values for these are approximately 1 plus square root 34 divided by 3, a 2.27, or 28 actually, and when I subtract, I'm going to end up with negative 1.16.